Hello, and welcome to the webinar on Preparing for Drought, the Role of Soil Health in Water Management in Organic Production. This webinar is part of the Organic Farming and Soil Health in the Western U.S. webinar series, organized by the Organic Farming Research Foundation with funding from Western SARE. I'm your host, Alice Formiga of eOrganic. eOrganic has many articles, videos, and webinars about organic farming and research, and you can find all of them by typing eOrganic into a search engine, and you can also find the recordings on the eOrganic YouTube channel. We're recording this webinar, and we will have the recording available on YouTube within 1 to 2 weeks. The webinar will last approximately an hour, and when it's over, we'll have 30 minutes for questions. If you have a question, feel free to type it into the Q&A box on your webinar control panel at any time. If you don't see the Q&A box, if you hover over the bottom of your screen, a black bar should come up with some controls at the bottom, and you can open up the Q&A box, and you can also open up the chat box, and there you can type in comments if you have anything you'd like to share with everyone, and you can address it to just the panelists, or you can address it to the panelists and the attendees, whatever you'd like to do. So I'd like to welcome back the main presenter of this webinar series, Mark Schonbeck. Mark is a research associate at the Organic Farming Research Foundation, and he's worked for 31 years as a researcher, consultant, and educator in sustainable and organic agriculture. We also have Scott Park, who's a farmer with Park Farming Organics in California, north of Sacramento, and he is going to be online, and he's going to talk a little bit about a project that's been going on his farm and be also online to answer questions. So we don't have a picture of him, but welcome Mark and Scott, and I'm going to hand over the controls now to Mark Schonbeck. So Mark, you should have control if you click on the screen.
Okay, I clicked.
Okay, hopefully sometimes it takes a couple seconds.
Thank you for attending, everyone, and I'll get started. Let's see.
Okay, sometimes it takes a couple seconds here. Let's see. Click on the screen again, see if you're, yep, there you go.
Okay, great. All right, well, I first wanted to briefly review the results of a survey that the Organic Farming Research Foundation conducted in 2015 of organic farmers all across the country, including 555 in the Western region. And as is true of all regions, the Western region farmers rated soil health as their top research priority, with 71% considering it a high priority. And another high-ranking research item was irrigation and drought management. And some specific areas of interest within that is how building healthy soil enhances both water and nutrient management, designing drought resilient systems for both crop production and pasture, the challenge of cover cropping with limited water, and we will definitely look at that later on in the webinar, and also how the soil biology and nutrients behave in drier climates, and whether compost will help with water availability in a dry climate. Okay. So I'll just take a few quick comments here on water quality. Obviously, production affects water quality in terms of whether and how much nutrients leave the field in leaching and runoff. Livestock operations, there is a potential of manure pathogens, and of course, eroded soil affects water quality through sediment. And in turn, water quality affects crops, primarily when you have issues of salinity or alkalinity or high sodium in irrigation water, which I'm sure a lot of people on this call are more familiar with than I am, since I live here in Virginia, where we get plenty of rain and only rarely have to irrigate. And then, of course, the issue of if there are pathogens in the water, and that affects your food safety and salability. So just a very quick review of how water behaves in different situations. A lot of you are familiar with the fact that when there is more evaporation and transpiration over the course of the year than is received in rainfall in semi-arid to arid climates, there's always a chance that soluble salts will move towards the soil surface and create somewhat saline soil conditions that limit crop growth and also directly impact soil health. But in the situation on the left, something that really came home to me is that a lot of the most productive agricultural regions in the Maritime Pacific Northwest and parts of northern and central California, Salinas Valley, Sacramento Valley, etc., they have a Mediterranean climate where most of the rainfall happens in the winter, and yet most of crop production happens during the summer. And with intensively managed vegetable crops, of course, those summer crops are grown with irrigation. So what happens is then during the winter, there's nothing in the ground, and there's a great potential for nitrate leaching. Okay, we'll just very quickly look at how soil moisture behaves in the water. This will be review for a lot of people, so I'll just go quickly through it. So when it happens when it rains, the water first saturates the surface of the soil, and then the water in the larger pores moves down with gravity. It's deeper and deeper into the soil profile until all the small or capillary pores are filled with moisture, and the larger pores have drained back out and are once again aerated. And typically in an average loamy soil that with about half of the soil volume is made of solids, mineral, and a little bit of organic matter, and then the other half is pore space, and you have three basic groups of pores. The largest ones that drain out after the rainfall event has ceased, that becomes air-filled macropores, and at this point the soil is at field capacity. And then the medium-sized capillary pores hold what's called plant available or capillary water. It won't just drain out, but plant roots can access it relatively easily. And then there's a portion of the water that's so tightly held in tiny pores and it's tightly absorbed to the surfaces of the clays that plant roots basically cannot extract it. And that's sometimes called hygroscopic water. And one of the things we need to remember is that your inherent soil properties, the things that nature has given you, will influence how water behaves and how much water is available to the crops. So the first step towards managing the water is to get a good handle on what your inherent limitations or capacities are. Things like soil texture, sand, silt, clay, proportions, loamy or clay loam, soil depth and the profile. Depth meaning how far the plant roots will go down, how far to either bedrock or water table, and then drainage and permeability, and then the depth to a restrictive layer. That's a specific aspect of profile. All of this information can be found on the NRCS Web Soil Survey at this website, and you just type in your exact address location and you'll get a soils map of your fields. And just as an example, here is a soil in Corvallis, Oregon. It is a mollisol, and it's characterized as moderately well drained, so water will be a little bit slow soaking into that profile, but it won't be standing there for a really long time. Okay, so here's an example of variations in inherent soil properties. You have your sandy soil. That tends to drain out quickly, have more large macropores, so you have more air filled, and very little of this hygroscopic water and a relatively small amount of the water holding capacity. And if you have very clayey soil, surprisingly, you think heavy soil, you'd be more solids. There's actually less. But what happens is because there's so many fine pores, a lot of that water is unavailable. And your air-filled pore space may be a little bit less than you would expect in the loam. So you end up with a water holding capacity that might be a little bit less than a loam or a silt loam. And the other thing to remember is your plant, the amount of water available to the plant is a function of the water holding capacity, but also the depth that the plant roots can access. Now here is a best case example of a plant that can root quite deeply, go all the way to parent material, which is bedrock or broken up rock, really isn't soil anymore, what's called the sea horizon. But this root system can go all the way down to that. So whatever that depth is, for instance, if you're in a sandy soil and you only have a foot before you hit a hard pan, there's much less water holding capacity than you could be like an inch or two. Whereas if you have a loam with a really good holding, the WHC is, let's say it's around 20%, and then you've got a 5-foot soil profile, then you have a whole foot of plant available moisture at field capacity. Here's an example of a soil. It's in Salinas Valley. It's called a Chulawar Chualar loamy sand. And it's an RG xerol, which means the RG says that there is an accumulation of clays in the subsoil or B horizon. And that can be a source of moisture and nutrients, and it can be an important reserve, especially when the surface is very sandy, such as in this soil. And it is considered very deep and well drained, which means that the water will, when the rain comes, the water will soak down and will percolate in, will not have a hanging up water table. And yet, it is so compacted, sufficiently compacted to stop plant root growth at about 30 inches. So that now limits how much moisture this crop can get, and it kind of cuts it off from those deep reserves. Okay, now we'll look at management-related soil properties and how they can affect your water holding capacity, and also how that can be, the management can be changed to improve the water relations and the water availability. So in a healthy soil, this is an example of a loamy soil that's got really good organic matter that farmers taken really good care of it for years and years, perhaps farmed it organically, definitely grown a very highly diverse crop rotation with lots of biomass, lots of root activity, and was to begin with blessed with an inherent soil profile that was deep and open. So you have a situation, the rain comes down, soaks in easily, and it moves down the profile, and at each level, the capillary pores fill up to field capacity. The plant roots can reach it all. So one good heavy rain and you have really recharged that soil profile for quite a good period of time. And at the same time, when you do have too much rain, it easily drains out to get into the either into the parent material or to the water table, and then does not become a waterlogging problem. Okay, so here's some ways that healthy soils do keep the crops well watered. Soil organic matter in and of itself has a very high moisture holding capacity, even higher than the silts and the clays in the soil, which are the second highest. And in fact, a review of soils of the silt loam texture across the country found that for each 1% increase in soil organic matter, there was a 4% increase in water holding capacity. And that means that the size of the water hold of the plant available water on that pie chart in the previous slides would increase by 4 percentage points. And that's partly the direct water holding capacity of the organic matter, but it's also an indirect effect of good soil health, meaning that there's a network of pores open to the surface. The water gets in easily in the first place. Because it's well aggregated and there's a low bulk density, there is a large capacity. And then it's the biological activity and the biodiversity that maintains the soil structure. It maintains the organic matter and that structure and pore space. And then in the very best case scenario, the entire soil profile is open. You don't have any naturally occurring hard layers, et cetera. So all of those factors together contribute to this 4% increase for every 1% organic matter. Now that relationship will vary with your soil texture. It'll be a little different on a sandy loam or a clay loam. That was just an example from the 15th edition of Nature and Property of Soils. Okay, so what happens when you got a few soil health problems? Compaction can do a number of things. One thing, if the whole soil profile is somewhat compact, what happens is this water holding capacity gets squeezed in two ways. One is when the soil gets kind of dry, it's harder and harder for the roots to grow through it. And then when the soil gets a little bit moist, even close to field capacity, it's hard for the roots to get enough oxygen. The air-filled pore space has been crushed, so there's much less. So even when it's not even quite at field capacity, the oxygen levels may start to go down, and that will compromise root function and root ability to take up the moisture. The other thing is a lot of the capillary pores have been crushed to where they're now very tiny and hold unavailable water. And of course, in a compacted soil, your solids make up more of the pie chart. Another thing that can happen, another form of compaction, is surface crusting. That can be as simply a result of cultivating frequently and not having any protective residue or living mulch or organic mulch on the soil surface. The rain beats down, seals it off really quickly, and a lot of it runs off, so you're losing that water. It's no longer staying in the field. And the other thing that can happen is you can have a distinct hard pan that is not given to us by nature, but as a result of tilling to the same depth year after year. Sometimes called a plow pan or a tillage pan. Typically occurs somewhere between 4 and 12 inches below the surface. And if it's severe enough, it can stop root growth. And then you've reduced your plant available capacity again. And you get the other situation, what I call a depleted soil. It looks a lot like the sandy soil. It's just that you just don't have that much capillary pore space. And whatever your soil texture is, if it has not been receiving enough organic matter inputs, it has not been kept in living plant cover sufficiently to maintain that aggregation and the organic matter levels, then the capacity of the profile to hold the moisture decreases. So you may not have any drainage or waterlogging problems, but you've lost a lot of your water down to the water table and the plants can no longer reach it. Okay, so what happens when there's too much moisture? That affects soil health in a number of ways. Tends to create that surface sealing and clogging of the surface pores, and you get runoff and potentially erosion during this heavy rain or over irrigation. And the waterlogged state is harmful to plant roots. You've reduced your oxygen levels. The aerobic soil microbes either die out or go dormant. There's an increased risk of certain crop diseases, root rots that like those anaerobic conditions. Actually, I misspoke there. I would say hypoxic. The oxygen levels are depressed or not necessarily zero, unless you're talking about a rice paddy. And you can get certain weeds. The yellow nutsedge thrives in these conditions while the crops are kind of languishing because it's too wet. And in this partially anaerobic state, you do get a release of nitrous oxide, greenhouse gas. And since we're already battling climate change, we don't want too much of that. Okay, so at the other extreme, if it's too dry or in a dry climate, what happens is plants are not actively growing anymore. So your soil is not regenerating. The soil life gets hungry, goes dormant, plant growth slows or stops. You don't have as much root biomass and root deposition into the soil. So the total organic inputs diminish. And then during these dry spells, there's a risk of wind erosion and possibly fire. One thing that can happen is if you have a period of wet weather and then it suddenly swings into severe drought with high temperatures, your plants will have developed fairly shallow root systems, especially if there was a high water table during the wet period. And then suddenly swinging to dry, they may not have time to grow down and follow the receding level of soil moisture as the soil dries down the soil profile. And this sort of whiplash weather, which we've gotten all too familiar with lately, can just generally make crops less resilient. Okay, let's talk about some of the practical ways of managing managing soil water through organic production practices. The NRCS 4 principles of soil health management really good guidelines for water management, because when you keep the soil covered, you have much better infiltration. We'll see some dramatic examples of that a little bit later. And when you diversify the crops, you're using the water and nutrients more efficiently, because some crops root deep and some root shallowly. And there's a direct relationship between diversity and the level of organic matter. And then the living roots, they play the most vital role. They're continually feeding the soil biota and recreating that pore space and that water holding capacity. And then the less you have to do this, yeah, if you're going to plant carrots, you need a seed bed like that, but you don't necessarily need to be tilling all the time. So whenever you can, to avoid the tillage, and that'll get away from a lot of these factors that can limit your water capacity. Organic soil health practices, the National Organic Program mandates soil building practices throughout the standards. Crop rotations and cover crops, as I mentioned, they're constantly building the soil organic matter and thus both the holding capacity and the drainage. Compost plays an interesting role. It adds stable soil organic matter. It's particularly rich in organic matter that's going to stick around a long time. And it acts in a complementary fashion with the cover crops. The two together build more soil health outcomes, including water holding capacity, than either one alone. Mulching, it just conserves moisture and prevents crusting. And then but you can reduce tillage, as I mentioned before. Here's an example of some soil health practices that have maintained moisture availability for this squash crop. The roll crimped cover crop is a surface mulch, and the fact that it was terminated without tillage means less damage to the soil, avoided damage to the soil structure. Okay, compost, one thing to remember is it's great for that stable organic matter, as I mentioned before, but more is not always better, because if you put on too much, two things happen. You can build up your soil plant available nutrient levels just as much as you can with conventional fertilizers. So if you add enough organic compost year after year to build up those nutrient levels, you can actually get leaching and runoff issues with water quality. Another thing to remember is the excess phosphorus levels that can result from using compost or manure as your main source of nitrogen and organic matter. That'll inhibit mycorrhizal fungi, and they play a very important role in crop drought resilience, and they may even play a role directly in maintaining stable soil organic matter. So we want to keep those phosphorus levels moderate. Mulching definitely saves water, and the best forms of mulch are ones that act as a one-way valve. You have a porous organic mulch, or something like weed mat or landscape fabric. In both cases, any rainfall or overhead irrigation will soak into the soil, and then evaporative losses are significantly slowed, and they both act as a weed barrier. The weed mat is more effective even than the organic mulch. On the other hand, the organic mulch is actively feeding the soil, adding some nutrients, adding lots of organic matter, and helping to keep that structure and organic matter actively replenished. And here is a very common practice in both organic and non-organic production. This practice is allowed in organic by organic standards, so long as you can take the plastic out of the field at the end of the season. It's a lot of work. But the plastic saves a lot of labor with weed management and can help with precise water management, if you assuming you have irrigation lines underneath, drip lines, and also nutrient management. However, this is an example in California. This is some recently planted strawberry beds in an organic strawberry field. And you see the amount of ponding and even runoff, and so there's nutrients and soil being lost from the field. There's hardly any slope, but just enough for it to run out. And this is after a rainfall of only 0.4 inches. So it was not like a deluge. So that clearly illustrates the disadvantage and the potential water management concerns with plastic mulch. And that's a non-permeable plastic mulch, so it need to be specific there, since the weed mats are also made of synthetic materials, plastics. Anyway, so I'll just quickly talk about reducing tillage. Anytime you can avoid disturbing the entire field area, or even if you do disturb the entire field area, if it's done more gently, such as with a rotary spader, which is doesn't invert the soil profile, doesn't pulverize it. A rototiller can be geared down so that it does not completely break up the aggregates. And I'll talk about the sweep plow undercutter towards the end of the webinar. It's an excellent tool for undercutting existing vegetation without disturbing much of the soil profile and without burying the residue. Any of these things will reduce the adverse impacts of tillage on your soil water relations and water holding capacity. When livestock systems, there's nothing like management-intensive rotational grazing for sequestering carbon. That translates into building soil organic matter, which in turn means better water holding capacity. When these systems are properly managed, and it's typically, you have a high stocking rate, but any one paddock is grazed hard only for anywhere from 12 hours to 3 days. And then the cows are moved on to another paddock, and that paddock is allowed to grow undisturbed until it's fully recovered. And that cycle of intense brief grazing and recovery causes the forage to develop very deep, extensive root systems, slough a whole bunch of roots, which become stable organic matter and feed the soil biology and recreate all the soil, dynamic soil properties that support optimum water holding capacity. And then the forage grows back and maintains very high vigor and is very nourishing to the cattle again. So drought resilience of the forage and of the whole ranching system is a well-known benefit of these systems. And similar benefits have been observed all across the country, including Northern Great Plains, Texas, New Mexico, areas in the Pacific Northwest, as well as higher rainfall regions in the eastern half of the country. Well, we all know this, weeds steal moisture. So yeah, that's why conventional farmers get out there with the herbicides and the selective herbicides, so they only have their crop using the water. That's why we organic growers have to get out there with a steel sometimes and do a little bit of cultivation. One thing I want to point out is it's been found that one of the ways invasive weeds are invasive. This is an example that some of you who are ranchers out in the interior north part of the western region are probably very familiar with. This is Canadian or Canada thistle. One of the ways that it is invasive is that it is so greedy for moisture throughout the soil profile, and it can send its roots down 20, 30 feet. It'll parch the soil profile and squeeze out a lot of the desired native range plants. So that's one thing we got to watch. And there's some crops that we have to be careful about that for the same reason. Alfalfa is an example. It can grow roots down to 30 feet and it'll dry the soil profile excessively. Organic weed management, cultivation, timely shallow cultivation where you're just stirring the top inch is great for taking weeds out while they're small, keeping the crops ahead of the weeds. And there they are dying in the surface. And if you do that a couple of times before the canopy closes, you can get the surface sealing and crusting that you really don't want for both soil health and water holding absorption reasons. So good organic weed management combines a lot of practices, of which the cultivation is just one. Okay, well, let's talk about some stuff more relevant specifically to the western region. We'll start with irrigated crops. So a couple things to keep in mind. Overhead sprinkler irrigation, there is a greater degree of surface sealing and compaction from the impact of the water from above. Also, if you have rows and you have inter rows, it may not be as efficient in terms of getting water to the crop. In-row drip is excellent for that efficiency, and it's much gentler. You're not packing the soil down with simulated rain. I have heard that there can be a concern in a dry climate if you leave your alleys unwatered for long periods. The processes of mineralization by soil life that provide nourishment to the crops is slowed down. So there may be less plant available nutrients from the soil life under those circumstances. Irrigation challenges in arid regions. I'll just briefly mention this. It's book knowledge for me. I'm sure a lot of you are very familiar with this firsthand. Groundwater, which is often what you have to use for irrigation in many parts of the West, can be saline or alkaline. It can build up salts near the surface, which is harmful to soil life. And a high level of sodium will directly degrade soil tilth, cause it to seal together. You can get a loss in crop yields, and of course there's aquifer depletion to think about. Another thing about the soils in these very dry regions is because there's historically in their native state, they only have active plant growth a couple months of the year, up to 3 months of the year, and much lower total biomass. They do tend to be low in organic matter. Because of the environment, if they're irrigated and if they have some inherent mineral fertility, they can be incredibly productive. The difficulty is if you have any loss of soil quality that may result from irrigation or other production practices, it can be more difficult to restore soil health since you don't have the rainfall to be keeping living plant biomass active in there year-round. Here's a successful example with irrigated production in a very dry environment. This is Utah, some studies by the Utah State University, where they compare different methods of managing orchard floor soils in organic fruit and nut production. A number of studies have shown that if you leave the orchard floor bare, you have terrific degradation of soil quality. You can lose half your soil organic matter compared to a neighboring pasture or orchard with living mulch. And when that goes down, of course, your water holding capacity goes down. The really cool thing that Utah State found is that in an irrigated orchard, they're not going to grow these on 8 inches of rain a year, so you do have to irrigate. However, when they put legumes like trefoil in the alleys, and even put a shallow-rooted living mulch right under the trees where you think it would compete with moisture, all of these resulted in better soil health, better tree root growth and health, better tree nutrition from the legume in the alleys, and the water needs did not increase. So for the same amount of moisture applied, you have a totally living covered system with soil health accruing over time. And as a result, you may even improve your water holding capacity, maybe even reduce the irrigation needs. Okay, this is something that's practical, practical situation that's happened, developed in California with severe droughts for several years. The allotments, irrigation allotments available to tomato growers and other farmers went down. So Scott Park and Dr. Gauguin at University of California, Davis did some very interesting studies where they said, okay, what happens if we just shut off the irrigation 2 weeks early? I mean, like, just let the tomatoes finish ripening on the residual moisture left at 45 days before harvest rather than going all the way to 30 days, which is the conventional practice. The first year they tried this at Park Organic Farms, and the second year they tried it both in a conventional field nearby and at the organic farm. The first year, the result was stopping 2 weeks early saved a full 6 inches of irrigation water, 6 acre inches per acre. And yield was not affected, so therefore the water use efficiency went up quite substantially. And Scott Park uses a number of soil health practices, diverse crop rotation, winter cover crops, compost, microbial inoculants to ensure a complete soil food web, reduces tillage, controlled traffic so the bed tops are never compacted. And the result was that soil was able to absorb all of the rain that fell on it throughout the winter. And this is the second year study. This is the study on the conventional field. Now, all 4 of these treatments had fairly similar yields, all right around 44 to 47 tons per acre, which is excellent. And so in the conventional field, they had a standard irrigation and the deficit cut off 2 weeks early. And then at the Park Organics, the same thing. Now, the most interesting thing to me here is that even with a standard irrigation schedule, these tomatoes needed only half of the water. So their irrigation efficiency, their yield per acre inch, doubled. And then saving just 2 inches of irrigation water in the deficit treatment increased that efficiency substantially even more. And one of the reasons that these didn't show any significant difference is that the deficit actually did take a little bit of a yield hit, about 10%. Another thing that was observed is the organic field had better fruit quality, as shown by a lower percentage of fruit that were spoiled and couldn't go to market, and a slight but significant increase in phenols, which is a secondary compound that contributes to flavor and to canning quality. So, Scott, I'd like to let you add any comments here before we go on any further.
Yeah, that's I've been working with Dr. Godin on this every year. We're tinkering with water, how it's moving the soil, how it's carrying, is it carrying nitrogen down in the groundwater. Maybe it'd help for people listening to get a little feeling of my farm and what I'm doing. So I farm just north of Sacramento. I have 1,700 acres. It's all certified organic. I don't farm anything conventionally. I've been farming for 46 years, and the last 33 years have been pretty much devoted to building up soil health. So as times went on with continual positive serendipitous results, it's dawned on me through time the value of soil health solving, for the most part, almost all problems that farmers encounter. And all the slides that you've shown, for the most part, I am seeing it every day, at least every week, every month throughout. On this particular study, it's actually Amelie toned it down. It's actually a lot more dramatic on water usage. The water cutoffs, to give people a feeling for California farming, is most growers are irrigating up to 10 days before harvest with drip irrigation. In this particular studies, I was cutting the water 45 days before harvest. So I was going, for the most part, 30 some days, which is quite a bit without water. And then I also cut days. So that's a 2-week cutoff, but most growers are running the water significantly longer. Also, that doesn't show in the study is that I don't irrigate for the first 40 days when I put the transplants in the ground. So a processing tomato is grown over 125 days. And for the most part, by soil health, I've cut out the first 40 days of irrigating. I've cut out the last 40 days of irrigating. And my quality and yields my quality is better and my yields are certainly comparable to conventional growers. And basically it's all being done by having just I add 10 to 15 tons of biomass every year to every field in the form of cover crops, compost, or crop residue, and it's just depending on what the crop's following. But for the most part, the farm just cares about soil health and building it up, and that seems to solve a whole lot of problems, not just water and fertility, but also most major pest issues of insects and disease. If that gives the people a little feeling for what I'm doing.
That's great. It's great to hear. Thank you, Scott. Okay. Did you want to add anything more?
No, that's on this. That's I can ramble for put everyone to sleep. So that's
Yeah,
good.
well, that's excellent. That's exciting. Okay. Well, here's another example of irrigation efficiency by deleting some late irrigations. This is Dr. Bernadine Strick in Oregon State, looking at production of organic berry crops, blueberries and blackberries. For the blueberries, which are very sensitive to either too much or too little water, she found that in-row drip underneath that weed mat or perhaps under an organic mulch really works best. In blackberries, she found that if you just drop that last irrigation, you can save 2.5 inches of moisture and improve the winter hardiness of the crop. Okay, we'll look at some other the very specific challenge that I wanted to mention here in more depth. So what happens in these climates is most of the rain falls in the winter, but the crops are produced in the summer. The rotation is either a long season crop or 2 short season vegetable crops in succession, and then harvest sometime in October, November. Everything's cleared out and it's just left to stand fallow when most of the region's 10 to 15, maybe 20 inches of rain falls. So you can get ponding, you can get runoff on a sloping field, maybe even erosion, a lot of leaching of nitrogen to groundwater. Very often, even in organic production systems, as much as 100 pounds per acre of nitrogen. And then that late fall harvest makes it a little bit harder to get the cover crops in. Ah, there it is. Okay. So this was an illustration of the experiment that Dr. Kabir did, comparing just planting a winter cover crop versus a fallow. There's a nice solid winter cover crop, and there's a fallow field, and the equipment that he used to measure runoff. The thing that's fascinating to me about this is that in that upper field, you see all that ponding between the raised beds, that was left fallow. And down below, the cover crop was planted. Now, it was planted late, so you don't see this beautiful, thick, massive cover crop. You see a little thin cover. And yet, this created enough of a difference that you have really badly ponded soil up here. And down here, yeah, it's too wet to walk in or till, but it's not ponded. And indeed, this field retained 90% of the moisture that fell during January through March, and this retained only 50%. That was data that Dr. Kabir collected for this project. Okay, now this is very interesting. This is after a pretty heavy storm in Solano County in a walnut orchard. It kind of looks like a hurricane disaster zone on the left there. And that's, again, with just a low-growing cover crop, just simply maintaining the soil by keeping it covered. No standing water. And you get a situation like this, you will get greenhouse gas emissions, and you will get a very adverse, although perhaps not very temporary, but still adverse impact on the soil biology and soil health itself. Oh, okay. Let's see if I can get this to actually move. Okay. All right, and this is the next one. He was just driving down a field one day, and one side was cover crop. This is a late winter storm. It was about 2 inches of rain. And you could see, if you look at this field, there's a nice thick cover crop. There's no standing water, whereas this field has become a lake. That was after about a 2-inch rain. Okay, so I'm going to talk a little bit about several different trials that happened in the Salinas Valley, where the typical rotation is 2 short season vegetables followed by winter fallow. And what's going to happen during this winter fallow period is a lot of leaching of nitrogen and denitrification. And what can happen is even with organic broccoli, the economic sweet spot in terms of how much nitrogen to put on is around 200 pounds per acre or even higher. It's extremely heavy feeder and not very efficient at using that nitrogen. So what happens is farmers are realizing returns of anywhere from $4 to as much as $25 for every dollar they spend, even on an expensive organic fertilizer. So they're not going to stop at 40 pounds per acre. But then during the winter fallow, there have been some studies in California that show that you can have not only 1 to 200 pounds per acre of nitrogen leaching, you can have 10 to 20 pounds of nitrogen turning into nitrous oxide, which is a really potent greenhouse gas. And that much emission will offset the annual carbon sequestration of the best organic soil management system for crops. In this case, I want to thank Dr. Joji Muramoto for this slide, which he gave me permission to use. It's from a study in which organic broccoli grown in the summer, harvested in September, was then followed by strawberries who are not going into winter fallow, saying, okay, we'll get the strawberry crop going as soon as the broccoli comes out. And then the next season, the strawberry harvest. Unfortunately, the tremendous amount of nitrogen left over, plus that return to the soil in the residues and in the starter organic fertilizer for the strawberries, all of that is leached out by winter rains. You see that it's going, the top foot has over 250 pounds per acre of nitrogen, and that drops all the way down to about 25 before the strawberry crop begins its active growth and active uptake of nitrogen. However, instead of planting strawberries, let's plant a winter cover crop that's going to grow vigorously all through that winter season. So what happens is, in this case, the cover crop is absorbing a significant amount of that nitrogen. In a conventionally managed rotation where 2 crops of broccoli were grown and each one received an incredibly high input of nitrogen, somewhere around 200 pounds, more than 200 pounds per acre for each crop, simply putting in a crop of rye or of Phacelia that grew to only a moderate biomass of 3,200 pounds per acre reduced the nitrogen leaching by 2/3. Now, it was still higher than desirable because in the fallow, you leached over 200 pounds of nitrogen. And then getting that cover crop in there, it got it down to about 60 pounds. And that was partly because there was less moisture moving down out of the root zone. There was less drainage by about a third. But it also, some of the nitrogen that was in the soil profile was actively absorbed by the cover crop. And in some trials on organic production systems, Dr. Eric Brennan at the Salinas Valley Research Station, he was growing spring lettuce followed by fall broccoli and then a winter cover crop or a winter fallow. We tried various combinations of various rotations where the winter cover crop was in there every year or where it was just every fourth year. Fascinating result. He used a moderate amount of nitrogen on this broccoli, about 145 pounds per acre. And whenever there was a winter cover crop, you got 1,000 boxes per acre of lettuce, which is 30 pounds per box. You're looking at 15 tons per acre, pretty good yield. Every time there was a fallow, there was either a severe yield loss or a total yield failure, very rarely as much as 500 boxes. What's going on? Well, it didn't matter whether this was a legume or a brassica or a cereal grain. Same result. It's not the nitrogen fixation, it's the nitrogen recovery. I thought that was very fascinating. And it's very telling. So I say, why isn't every California vegetable grower cover cropping every winter? Because even if you're not worried about the climate or about leaching to the groundwater or the state environmental agency getting after you for leaching, think of the savings, think of the yield increase, and think of the reduction in need of fertilizer, just having that cover crop in. Well, it's not always easy. The timing can be really awkward. And I lived in California once many years ago, and I can remember years when the rain set in September and they continued until May, and then other years where we were out there Christmas shopping and looking at the sky and praying for rain. So you can get a very early onset to the rainy season, or you can get a very late onset. So let's say you're Scott Park and you shut off your irrigation a month before harvest, let the water start drawing down, and then you harvest and you say, okay, I'd like to get the cover crop in tomorrow. Well, suppose the rain's already started, you may already be too wet. Or if it's one of those years where you're praying for rain until New Year's Day, it's too dry and you can't get the cover crop to come up. So this can be pretty challenging. Well, there's one low-tech solution that a number of farmers have used, interseeding the cover crop into the standing vegetable. Here's two summer vegetables photographed by Nick Andrews at Oregon State University. This is eggplant into which oats were overseeded, and this is taken after the frost has killed off the eggplant. Down here is winter squash just before harvest. The vines have died down, either the first touch of frost or maybe a little bit of disease, but close to harvest ready. In both cases, the ground's already covered by the cover crop. And since you're irrigating the vegetable, well, you're irrigating the cover crop too, gets around the issue of dryness. Here's a kale crop in mid-growth, and there's just lines of young legume crops growing between. So when the kale harvest is finished, that legume will pretty much cover the field. Here's a different application, again, research by Eric Brennan in the Salinas Valley. This is, again, those plastic mulch strawberry beds that have a real problem with shedding moisture and runoff. And so he's planting a cover crop in between. Now, they worked with cereal grains at first, but the problem with the grains is that they were difficult to manage because they would grow up so tall that they would start to shade the strawberries and limit yield. So they're now using mustard, which is easy to control with a weed whacker just before it begins to shade the crop. The main benefit is that this reduces the amount of water and soil that rush out of the field. It's reducing the intensity of the runoff, and it is capturing some nitrogen. All right, well, let's look at what happens when you're dealing with very limiting moisture. Dry land grain production is a major production system, as I've learned a lot about just by reading about it and looking at other webinars and such. So you got three main types of plant just vying for that little bit of moisture that comes down 10, 12 inches every year. You got your cover crops, if you want to try to get one in the rotation. You got your grain crop, you got the weeds. The traditional approach to this is to say, well, we really need 20 inches to grow a really good crop of grain. So let's just let the soil stay fallow a whole year to gather up that year's 10 to 12 inches, save it up, combine it with the next year's 10 to 12 inches to grow the grain. Problem is, during those fallow years, the soil loses organic matter, it loses water holding capacity, it loses fertility, you get more wind erosion. Even in a continuous no-till system, several studies have shown a steady loss in organic matter and overall soil health during that wheat fallow, even on continuous no-till. And then on the other hand, you say, okay, well, we grow cover crops, that's going to make things better. There are a few limiting factors there too. On less moisture, you won't get as much biomass or nitrogen. The cover crops also will sometimes have to compete with the weeds. And if you're adding another crop to the rotation, you are using some moisture, which can result in decreases in the cash crop yield. So what we want to look for is cover crops that perform well in these climates and don't use too much moisture. You want them to be hardy to the drought conditions. You want them to be able to produce a decent amount of biomass and for a legume nitrogen. Want their moisture demand to be low enough not to interfere with production. And if you are coming into a dry period between your cover crop and your cash crop, you want to be able to just leave dead residue on the surface and not have bare soil. A couple of winners in this in these categories: pearl millet is a warm season crop. It is very deep rooted, and yet it is fairly efficient in its use of moisture. It won't totally deplete the soil profile. Gives tremendous biomass, can host free-living nitrogen-fixing bacteria in its rhizosphere, very beneficial. And if you have leftover nitrate, like if it's a Mediterranean climate and you're looking at some leaching, it will absorb all the excess nitrogen down to 5 or 6 feet, wherever its roots can get. Winter pea, this is a surprise me. This is Austrian winter field pea. Here in Virginia, I always thought of it as a winter crop that doesn't like drought, likes lots of moisture, and yet repeated studies in the northern Great Plains and in the interior Pacific Northwest, the Palouse, and in Northeast Washington. This is a winner for cool season legume cover crop. Uses very little moisture, and although it wouldn't tolerate the intense drought and heat of a Great Plains summer, it does fine in the winter season in the spring when there is a little bit of moisture available. So surprisingly good performer there, better even than lentils and much better than bell bean, which is not very tolerant to the drought. So if we look at drought resilience, there's really two axes that we have to look at: how resistant the crop is to drought, how much it can take the heat in the drought, and then how much water it uses. So we have several different patterns here. We have alfalfa, which I mentioned before as a water hog, sunflower and safflower, which are some oilseed crops. They're drought resilient because they have massive, deep root systems that can effectively take up soil moisture. So they have high moisture use. At the other extreme, you have things like pearl millet, cowpea, phacelia, surprisingly, barley, and the medics, the black medic. They're very drought resilient, but they don't use much moisture. So they're really a win-win for your really dry seasons. Sun hemp and sorghum Sudan, which are highly recommended for hot, dry summers and what we call hot, dry summers out here in Virginia, where, it gets a couple inches of rain, which would be totally luxury for those of you in the northern Great Plains. They're kind of in the middle. They're moderate water usage and are considered pretty drought tolerant. Field pea is in medium drought tolerance, but that because it is growing in the cool season, it's able to hang in there. Whereas you look at fava bean or bell bean, it's actually down here, it's fairly low in drought resilience. So that's those are the two factors you want to look into when you're choosing cover crops for these situations. Specific examples, some research that was conducted in the Central Valley of California at a USDA research station. An area where they get the winter rains in the Mediterranean climate, but they're relatively limited and they're quite unpredictable. Some years, like I was mentioning before, some years you get a lot of rain early and then less rain late in the season. Other years it's the reverse. It stays dry until February, and then down you get 6, 7, 8 inches of rain. The most commonly used cover crops in those regions are the vetches, the field peas, and the bell beans. And they do well if they get enough rain in the fall. If you get a good amount of rain at the beginning of the winter, even if it dries down later on, they'll give you good biomass, good coverage, etc. But if you have the reverse, they tend to fail. So that's one of the reasons why cover cropping is not done as consistently in these challenging environments. So they conducted a really interesting trial in a year that would have been indeed awkward for these crops. They did pre-irrigate by 2 inches. They put on 2 inches of irrigation water just before planting the cover crop in November. And then it stayed dry for a while. So they just came up on that little bit of irrigation water, and then they got almost 6 inches of rain in February and March. A variety of brome called Cucamonga California brome. It's not the same as field brome or soft brome. And then a specific kind of mustard, Braco white mustard. They gave incredible biomass, over 5 tons per acre. Here's an example of a biculture of those 2 cover crops. The coverage that it achieved in April, planted just on that little bit of moisture. Triticale was interesting because it gave a good biomass, and of all the cover crop treatments that were tested, it left the greatest amount of soil moisture as of April. So these were consuming a little bit more soil moisture. The Northern Great Plains, some research by Montana State University included a survey of farmers, and this surveyed about 165 farmers in the region to ask them about cover crops. There was a lot of interest because of a very high awareness of the soil health benefits of cover crops. 30% of the farmers were actually using cover crops, and their 2 main reasons were for soil health and to provide grazing. And research did show that cover crops added to the rotation in lieu of the wheat fallow can indeed reduce yields. And the 2 factors were the water use and the nitrogen use by those cover crops. However, when they varied the planting dates, either planted in the fall or very early in the spring, and they terminated the crop a little earlier than normal, like you do it at first flower rather than letting it come into full bloom or late bloom, that reduced the water consumption and yield costs of the cover cropping, and sometimes eliminated any yield loss whatsoever. Other times it was a small yield loss. And again, their recommendation is to use the winter pea, and avoid water hogs like alfalfa. Black lentil is an excellent production crop to consider for the rotation. Doug and Anna Crabtree at Villicus Farms in northern Montana have a very highly diverse rotation of lentil, of pulses, oil seeds, cereal grains, including some specialty grains like Corazon wheat and spelt, and 10 different species of cover crops. They never do a full year fallow, and they've had great success overall, although there was one year that was just extremely dry. It was, I think I had 2 or 3 inches of rain. And that is a real issue that's going to be perhaps increasing as the climate change situation develops. Now, this was something that was very interesting to me. On very similar amount of annual moisture, another semi-arid region in northeastern part of Washington, the big difference is in Montana, the rains and snows come scattered rather evenly over the year. I mean, it's, not consistent year to year, but your average of 11 inches is evenly distributed around the calendar year. Whereas in Northeast Washington, almost all of that comes as winter snow. So you have an extremely dry summer and you have a cold, snowy winter. Also, the soils are kind of shallow and stony. They're not the deep, highly fertile prairie soils and Palouse soils that you get in Southeast Washington and in the Northern Great Plains. Once again, they had 20 farms working with the NRCS and a conservation innovation grant where they were just looking at, well, how can we get the most soil health benefit from cover crops without hurting our wheat yields? Well, again, they found that the winter field pea worked the best, but in this case, spring planting is better because if you plant in the fall, you're planting into bone dry soil, you're dusting in the seeds, And then when the snow melts, the seeds have lain there and the weeds have gotten started. The weeds get the jump on the crop. Whereas if you plant in the spring, your planting operation is probably taking out the weeds with shallow tillage and getting the cover crop planted when there's plenty of moisture and it's going to pop up and start growing. The wheat yields in these 20 farms and 4 years of trials varied from as low as 34% of the control. And the control is a wheat fallow rotation maintained either with tillage or herbicides during that fallow year. It's not at all, these were not all organic farmers, but anyway, so their yields varied from a very serious loss to a significant improvement, with the average being a very slight loss of about 5, 10, 15%, something like that. So there was a tendency towards loss, but the big factor turns out to be not so much how much total moisture was used, but whether the soil was thoroughly dried out to the depth at which the drill will plant the wheat. So if it was dried to less than 3 inches and the grain was able to be planted into moisture between 3 and 4 inches, there was no or very little yield loss, and sometimes a yield improvement from the cover crop. If the soil profile dried to more than 3 inches, especially more than 4 inches, then you start getting these severe losses. And that's because the grain didn't have enough moisture to germinate. And very simply, the farmer is, one thing they can do is just go out there with a soil core and just watch the soil moisture, and that'll tell them when it's time to terminate the cover crop to make sure the wheat has enough. One last thing I just want to, I have not met one of these implements in person, as I have not had much experience directly with dryland production of grains. But the more I read about this, the more I'm impressed with this tool. The blade plow or sweep plow undercutter, you see these wide blades, it basically cuts everything off just below the soil surface. It'll take out weeds, it'll take out cover crops, knock them out, and yet you're leaving most of the residue on the surface. You're leaving most of the soil profile undisturbed. You're saving moisture, you're reducing wind erosion dramatically. And this method of tillage and managing cover crops pretty consistently improves yields over other methods. Okay, well, thank you for your attention and patience. It did go a couple minutes over, but open discussion now.
Yeah, thank you, Mark, and thanks, Scott, as well. We're going to start our question and answer time for the next 30 minutes. So we have some questions coming in. One of them is, this looks like more like a comment than a question, but somebody's saying that in dryland wheat fallow, 50% of rainfall is lost to evaporation, and a multi-species cover crop reduces evaporation and uses it to grow cover and fertility. And this is from modeling by the NRCS. So thank you for that comment. Does anyone, Mark, do you want to say anything to that? Or?
I say, well, that explains some of the results I've been seeing, and it rings true to me.
Okay, here's a question. Are there any cover crops that can provide cash to the farmers and at the same time provide health to the soil?
Well, the definition of a cover crop is that it is not grown for income. One way to kind of end run that a little bit is to use the cover crop for grazing. If it's done carefully, you do not lose very much, if any, of the soil health benefit. In fact, pearl millet and sorghum Sudan grass grow back vigorously after being cut at a certain stage. So I would imagine that grazing would have the same effect. And when they do that growing back, their root system goes even deeper and gets even denser. There may be some moisture use issues around that. But I mean, I always thought that daikon radish or tillage radish, if you're growing it, if you harvested 1 out of every 5, you'd have a nice market crop and the rest can be cover. Austrian winter field peas grow some of the best pea tips in the world, and you do 1 harvest of pea tips for market, you'll hardly dent the cover crop. But if you are cover cropping and receiving NRCS cost share, there are probably some pretty strict limits on what you can do in the way of marketing. Because a cover crop is defined as something you're not growing for income.
Okay.
Let me add to that.
Yeah, sure.
So some of this is a mindset of when your farmers are farming, that if you're looking for instant gratification, then sometimes cover crops don't work, but you need to see the advantage that what you're going to get is over time. And dollar-wise, it might not be an immediate jackpot, but the overall gain over time, you're going to make a lot more money in every aspect of the operation. It's not just yield, you know, or your money put out, but it's overall the streamlining and lessening your risk and having more resilience, so that if the weather's not quite right, the one thing you can't control, your plants are better positioned with better root systems to take it. So cover crops should really be seen in the long run in every aspect of your operation.
I want to add one thing to that. Go back to that slide where I was discussing the rotation in the Salinas Valley. If you go lettuce, broccoli, cover crop, and then come back to lettuce, you don't need any nitrogen to support that lettuce yield because a cover crop is feeding it. And that's in a particular environment. It may be different in others, but that was a direct and fairly quick turnaround in terms of benefits.
Yeah, I can get like on my farm, we have a specific buyer that wants no inputs, period, not even organic inputs. They want zero, and they will pay any amount of money for the rice to get it that way. And so I started growing rice in 2014 for this it's a small buyer, but it's a buyer. Anyway, I'm growing, cover crops are my only input on this ground, and my yields, this is being farmed with, again, cover crops, 2 years, nothing but cover crops as inputs, and my yields are as high or higher than conventional. And some of that isn't just the cover crops, it's cover crops. This has been going on this ground for, 25 or 30 years, and so the soils build up, and the quality and the yield are excellent, and your inputs are, how can you beat that? Water, seed, and cover crop. So, there's no question that what I'm seeing on my farm, and it's a high value, high risk business that I'm in, they definitely pay their way over time.
Great. Okay. We have another question here. What are the best methods to baseline and measure the biological living component of soil organic matter?
Oh, good question. The NRCS is actually working on different measures of soil health. There is an interesting organic matter fraction called permanganate oxidizable carbon, and it seems to be an index of biological activity because it's a recent product of soil microbial activity on organic inputs. And it's a form of active organic matter, but it also foretells the longer-term increase in stable organic matter. It's like the first step of conversion of fresh residues into stable organic matter. There are direct microbial tests that's found that a 4-day respiration test. Now, these are not things that a farmer can easily do in the field, although I think there is now a field kit available for the permanganate oxidizable. And you can do a simple 24-hour respiration test and a kit called a Solvita test. But it's not quite as precise as the 4-day. Those are two promising ones. There's some more complicated laboratory studies, protocols for discerning different components of the soil food web. Interestingly enough, the NRCS just had a comment period late last year on a proposed new technical note covering best ways to measure 6 different parameters of soil health. One being an improved approach to measuring total organic matter, one being permanganate, one being the respiration, various enzyme levels, etc. Anyway, that's a good question. It's a kind of a cutting edge and very necessary area of research. How can we get it to something that you can actually go out into the field, like with a penetrometer, and find out where your compaction layers are? It'd be nice to go out there to get a really quick take on soil biological activity and balance. Excellent question.
Okay, here's a question about whether home lawn grass can sequester carbon from the air.
Lawn grass?
Yeah.
The way to manage grass for carbon sequestration is to pretend you're a buffalo herd that visits it 2 or 3 times a year. That means mowing it 2 or 3 times a year. You grow it up 2 or 3 feet, cut it down, let the roots slough and let the whole thing completely regenerate. But if you mow it like a lawn, you keep interrupting the process when the plant is barely getting going again, which is why lawns are so difficult to keep healthy. And why you get thatch. You get this very shallow layer of organic buildup, and you have almost no root depth. Darn good question. Probably the best choice would be some naturally low-growing grasses that you only have to mow maybe once a month. And you could get something that looks like a lawn and yet has more root mass because they're varieties or species that emphasize root development and don't have like really tall top growth.
Okay, amazingly, we don't have any more questions in the queue, but so if anyone's feeling shy or feeling like we wouldn't get to their question, let's just give you another minute to go ahead and type in your question. It's a great opportunity to ask both Scott and Mark anything that you want to know. So at least about this. So, all right, so let's give it another minute or so. And meanwhile, let me just put up the link to where you can find all of the webinars in the eOrganic archive. And also, I wanted to mention the Organic Farming Research Foundation Soil Health Guides, which Mark contributed quite a bit to. And they can be found on the Organic Farming Research Foundation website. And if in the future you have any kind of general organic question, you can feel free to use the e-extension Ask an Expert service. So meanwhile, we did get another question, and that is that lots of coastal California vegetable growers are reluctant to grow winter cover crops because of delays planting in the spring. Do you have any thoughts about that? I know you talked a little bit about that.
That is a good question, the spring delays. If you're planting an early crop, you might need to grow something that is fairly easy to kill by mowing, like that mustard. Of course, you don't want mustard ahead of another brassica. It depends on where you are. You could grow a crop that will eventually winter kill if you're in a part of the California that reliably gets a good freeze at some point in the late winter. I would say, another possibility, it could be the undercutter, although that doesn't work as well in moist conditions. Yeah, that is a good question.
I'm faced the question every year on every field that's not a cash crop at that time on cover crops, because I'm growing winter cover crops into spring plantings. Of everything I'm planting in the spring, I've got a cover crop growing. So I face it all the time. I'm facing it huge right now because I haven't been able to get on the ground for quite a while. And we're just being able to roll actually in the last 5 days. So ideal scenario, yeah, you can grow cover crops. What you want to grow is legumes, particularly like I go pretty heavy with vetch. If you got a mix of grass or ryegrass or even cereals, but that causes a lot more complications. The root system's a lot denser. I find that it tends to dry out the ground a lot more and makes your tillage more difficult also. So the best thing, like what I've just found through 30 some years of growing cover crops, is to lean more toward the vetches. An ideal scenario is when weather, which is in California, which is normally there's a dry stretch in the winter in late February or something near there, then you go ahead and chop and lightly incorporate it, then walk away from it, let all the microorganisms digest it, then it brings up a wave of weeds, of the spring weeds come up, and then like 2-3 weeks later, whenever the next rain pattern lets you get in, you lightly scratch it and plant. All the biomass is broken down. You've gotten the advantage of the cover crop all winter, and you don't have much of a delay from one plant growing to another plant. So that's in 10 maybe out of 11 years, that's the way it works. This year it's not working that way, but I'm still turning around. I've got fields full of mostly mustard and vetch right now that I'm still chopping, lightly tilling, and in fact I'm planting corn right now in exactly that scenario. So, but again, this takes when you first start going a heavy cover crop, it's like your soil life, the soil food web isn't jazzed. It's not running on all cylinders. So the first years, your breakdown process, you tend to have more tie-up, more impact on that spring planting close to putting the cover crop under. If it's a little bit of a delay, like I'm talking about, if you can do something late in February and then plant middle March, it's only win-win. So, you know, there is some risk involved, but there's also the rewards over time. And if you never take any risk at all, you never get anywhere.
So we have another question for you, Scott. Someone would like to know if you're seeing more farmers heading in your direction for farming practices.
That's a question that I get quite a bit. I do a lot of stuff with particularly the UC system and with government, with NRCS, and people wonder if farming is moving in a more positive direction. And I would say unbelievably slow. And I mean, I'm like farmers around my area, they've been watching what I've been doing for 30 years. And you know, I mean, I'm doing very well. I don't mean to brag, but it's like, I'm doing well. I'm making a really good living. I take really good care of my employees. But overall, I would say the movement is way too slow. And the other question is why. For the most part, the government and academia still aren't making a good case to the farmer on how it can be profitable. And there's this separation between farming thoughtfully and making money. And I'm finding the two go hand in hand. And that point isn't being made well enough through the government and through academia. It's like if you're farming thoughtfully, if you're growing cover crops, if you're trying to have something alive 365, that's really good for the environment, but it's not good for your pocketbook. And that's not true. But it's still, to farmers, they don't hear it clearly and supported from government and academia.
Okay. Here's a question about the blade plow. Mark, do you know where it's being made and whether or not it's being used yet in coastal Mediterranean zones?
Good question. That really was aimed at the more semi-arid situations. Somewhere I saw some research or some information to the effect that when the soil is wet, it doesn't terminate cover crops very effectively, and of course it'll smear. You can imagine what dragging that great big plow blade through a very wet soil surface would be like, as opposed to using it in drier conditions.
And I'll add, because I'm dealing with that sort of stuff all the time, is the other thing is you can't do it too dry. Okay, if you do it too dry, it's going to have this lifting, shattering impact unless your soil is just in really beautiful condition. Like we do that. We don't have what that's called what plow?
The blade plow.
Blade plow. So like what we run are just like knives that come off a standard, coming all our grounds on beds, in which that bed plow would work. Blade plow would work much better because it would sneak in from the side of the furrow and make that cutting, but your timing would still be almost as sensitive to the dry side as it is to the wet side. But that idea, you don't need to spend money on an expensive plow. One, if you have your crop you're growing is on beds and you have a standard come down off some type of implement and you're pulling down just, plow steel that you're bolting a knife on, and then the knife's cutting from the furrow in toward the center of the bed, you can duplicate the same thing. The one problem, if you run it when the conditions are perfect, see, I've made so many mistakes. I've got lots of experience on what not to do. So we do that and we run it, but what happens is you cut the roots. So that's good. But the problem is if the moisture's good enough, the roots just regrow. So for a week, you're applauding yourself on how brilliant you were to go through and just cut the roots without disturbing anything. And then the next week, the plants have grown back because the plant's survival ability, they'll just put new roots on and grow right back. So they're shocked, but they also recover.
Yeah, I think
So
that was
we
one of the
run,
points.
so what we do is we run 2 sets of knives. And if anybody wants to do it, what you do is you weld a little piece of like a roll bar on your knife. And what that does is the knife goes through and it cuts, and the little roll bar on the back of the knife lifts up the roots, and it like breaks the connection of the roots with the soil. So we'll hit it once, and then we'll hit it twice, and we'll have a second knife behind it. And that double shattering with a little bar, anything where you get it, not just a knife cutting, but a knife and a lift. And that knife and lift shatters that connection between the soil and the root, and you have a better chance of it drying out and dying.
Wow, that's very interesting. Thank you.
Yeah, it'd be great to get a video of that.
Yeah.
All right. Well, thank you both. And thanks everyone for the great questions. It's been a really wonderful webinar and discussion. And we had a person online who really liked Scott's expression of farming thoughtfully. And that's a great way to end here. As I mentioned, you'll be able to find the recording in about a week on the eOrganic YouTube channel, and we'd be very grateful if you could fill out our follow-up email survey, which you'll get later today. So thanks so much, Mark, again, and for Scott for joining us. It was great to have you, and we hope that everyone online can join us for the other webinars in this series and all the other eOrganic webinars we offer, which you can easily find by just typing webinars by eOrganic into a search engine. Thank you.
Yeah, thank you.
Thank you. All right. Bye.
Bye.
Bye.